Okay. So let's begin. So I'll be speaking in English today. If I speak too quickly or I say something you don't understand, please let me know. I'm more than happy to explain any concept again. So today I'll be talking about product engineering. I've spent a lot of time working with startups. I've worked in big companies. And companies tend to have different marketing strategies, different sales strategies. They have different organization charts within the company. But one thing that I've noticed that is a constant across every successful company that I've seen is this. They all have a great product. They all have a great product, every single one of them, right? It doesn't matter what kind of marketing strategy you have. It doesn't matter what else you do. If you don't have a great product, you will not be successful. I've never seen a successful company with a crappy product, right? So today, I'd like to talk to you about my experiences of building products, specifically software products. So let's dive right in. So the first thing, think before you start coding. So what do I mean by this? The first phase that I always go through is an analysis phase. And what do I mean by this? In analysis, you ask two questions. What problem am I solving? And the second question is my proposed solution and actually solving the problem I'm attempting to solve? If it's not, I'm doing something wrong. Too many people are focusing on building features. Don't do that. Features are an afterthought. They come later. First, figure out if you're actually solving the problem of your client. The problem with features is sometimes they actually introduce more problems than they solve, right? So be careful about what features you add to your product. Sometimes you have a client who tells you what features they want. Still, remember that you are professionals. It is your responsibility to not only implement the feature, but to first and foremost understand, does this feature actually solve the problem that the customer has? Customers, regardless of who they are, will often tell you or ask for features that don't actually solve their own problems. Oops. Right. So be aware of this and always first and foremost understand, does this actually solve the problem that they're trying to solve? And if it does not, don't do it. Next comes architecture. We all understand this. This is the high-level design of your system, right? This is the zoomed-out version of what pieces we're going to have, how they're going to talk to each other. Fine. Next comes the design phase. This is a phase that engineers very often skip as well. This is where you try to actually understand at a low level. This is the part where you try to understand what are the individual pieces that you're going to have, how they're going to interact with each other. In other words, this is where, pay attention, this is important, you try to understand the contract that the pieces of your software have with each other, the agreement. These are the APIs and the behavior that you expect from calling these services. Why does this matter? Once you've understood how these components are to speak with each other, you should write it down. Makes sense, you might forget. But how do you know? If you think about it, your system is composed of pieces, right, that have to talk to each other. Each piece has a contract. It has made a promise to the rest of the system that it will have a particular behavior, that given some input, it will have some output. When you're writing code, how do you know if the code that you've produced is going to keep this promise? How do you know that later, when you modify the software in the future, that the promise will not be broken? The answer to this is simple. When you specify exactly what the behavior should be, your spec, you should implement your spec as a test. Turn your specs into tests. That way you are validating what you're writing. You are making sure that you are fulfilling the promise that you made in your spec. Later, when you modify the software, you rerun the test and assert that you didn't break your promises. The more promises you have, the harder it is to keep them. Remember that. So having tests that will make assertions for you automatically without you having to go through and manually test everything is a good thing. Write tests. Complexity is the enemy of software. Douglas Crockford says this. I agree with him 100%. Software engineering, programming, is the most complicated thing that people do. The reason why I think this is so, it's the most complicated thing that people do. Let me explain why. We have a contract with the computer that says this: our programs have to be perfect in every way, for every possible inputs, for every possible state. And if it's not perfect, the computer has license to do the worst possible thing at the worst possible time. So that's not good, right? Okay, so what do we do? Well, in the 60s, people understood that this is a major problem. And they tried to solve this by coming up with this thing called proof of correctness. This is attempting to use mathematics, mathematical proofs, to show that software is correct. It failed. The reason why it failed is because the mathematical proofs that they achieved were actually more complicated than the systems that they were trying to prove. Elika, լրիվ ազատ աստեղ, ասեմ իմանանք, այսանց, ընդեղ էլ ազատ, ընդեղ էլ, գիտեք, so that's bad. So, so we can't, how do we achieve perfection if we can't even recognize it when we see it? Tests don't help, by the way, because tests only tell you when there's a bug. They don't tell you about non-existence of bugs. So you can't know if your software is perfect by writing tests. Not to say you shouldn't write tests. You need tests. It's all we have, but it's not enough, right? This is why test-driven development, while it's important, don't take it as a religion. It's not the be-all, end-all. It will help you, but it will not solve your problem. So what are some things we can do to minimize complexity in our systems? An obvious one: write less code. The more code you have, the more complicated your system will be. This is a fact. The more code you have, the more bugs you're going to have, the more code you're going to have to read every time you try to modify your software. There's just more room for error. Do everything you can to write less code. Whenever I'm attempting to come up with a solution, whether it's at the design phase or implementation phase, first thing I do when I'm trying to think of a solution is anytime I think of one, if it's small, I know I got it right. It's a very good indicator that if you came up with a small solution, it's probably a good one. Right? So I'm not saying build stupid systems. I'm saying build awesome systems, but write as little amount of code to do it as you can. Second is to leverage frameworks. Leverage libraries. Leverage the code that has been written by other engineers to make your systems less complex. Write less code. Remove dead code. I've seen so many systems that have code in them that never runs. It's useless. Remember, in order to be useful, it has to be used. If it's not used, it's useless. When does this happen? During refactor. Sometimes someone will change an implementation of code that will lose the dependency on another piece, and now that piece is sitting there and isn't actually used. That's one time where you can end up with dead code. I've also seen engineers that implemented additional code thinking that it might be used in the future. Okay, don't do that. If you think if you want to, that's checklist. If you want to write more code that you think will be used in the future, fine. I'm not saying don't do it, but don't put it into the product. Take it out, put it into a different project. Or open source it, throw it on GitHub. Let other people use it, right? But don't put it into your product. All you're doing is complicating the existing code base, right? So take it out. No dead code. Don't fall in love with your code. Another way of saying this is don't be too emotional. If there's a better way to do something, do it. Throw away what you did and do it right. Do you guys remember go-to statements? Anyone remember go-tos? Yeah, you remember go-tos. Anyone using go-tos? Oh, come on, dude, seriously? You read Dijkstra's paper on go-tos, okay? Yeah. So a lot of people, when Dijkstra came up with his paper on go-tos, where he basically proved very clearly that go-tos are harmful for software, there was still this emotional attachment. No, if you're writing something that is producing bad software, stop doing it. I don't care how much you love it. Love has nothing to do with this. Do what is correct. Be careful about language conventions. An example of this. In a lot of languages, it doesn't matter whether you put your curly blocks at the same line or in the next line. People get emotionally attached, nah, I like it this way, and they get into stupid arguments. It doesn't matter, usually. What matters is that you stay consistent within a company. So if one engineer is doing it this way, everyone should do it that way. But in some languages, it does matter, and conventions are there to minimize mistakes. They're there to minimize bugs. Those of you who know JavaScript and don't work for me, what will this return?
Undefined.
Undefined. Why? Yes, exactly. So when you first look at this, you think, okay, this is a function that's going to return an object that has a name attribute with a string foo in it, right? But in reality, JavaScript has what's known as automatic semicolon insertion. And what it will do is it will insert the semicolon right there and return, well, nothing, which in JavaScript is undefined. So in JavaScript, we have a convention where we always put the curlies on the same line. And we have this convention, again, not for any emotional reasons, because we like it that way, because it's more beautiful. No, it's to minimize mistakes. Language conventions are there exactly for this reason, right? It's to help you write good code. So stick to them. Minimize the number of blocks that you make in your code. If you have a for loop and there's an if statement, don't wrap all of the logic with one giant, start here, write, this much code, and then end it here. Instead, just do if whatever, continue, and then underneath that, without any additional blockage, put in your actual code, right? The more nesting you have in your code, the harder it's going to be to follow your code. Don't use every single part of your language. A lot of people, they try to show off. They know these parts of a language that nobody else knows, and so they put it in because when they do the code reading, they want to be like, all right, look. So, two things. First, when you write something that nobody else understands, that's a bad thing, because that means nobody else understands it. I think that's obvious, right? That's a bad thing. Because you work in a team, right? Someone else might have to read your code. They might have to fix your code. Don't write something that nobody else knows, number one. Or at least if you do, educate them. Don't just sort of... Okay, so that's one. Two, understand that not all parts of a language are good. We all, hopefully, anyone who writes in JavaScript knows that JavaScript has bad parts. And it's not just JavaScript, by the way, but this is an example I'll give. JavaScript has a notion of a with statement. Anyone here using with statements? Good. Don't use a with statement. It's part of the language. You could use it. You could show off and say, nobody knows a with. I know a with statement, and I'm using it. But don't. It's a bad thing. It will introduce mistakes, errors in your code, so don't do it. Refactor ruthlessly and rewrite your code bravely. As you write code, as your code gets bigger and bigger and bigger, it's going to get dirtier and dirtier and dirtier, right? Think of your apartment. If you don't clean your apartment, it's going to get really nasty, right? Code is dirtier than your apartment. Every time you write code, every time you add features, every time you make modifications to your software, you will most likely make things just a little bit dirty. And over time, things will get dirtier and dirtier, more complicated and weirder, and eventually your software will just collapse. And you will not be able to push the software forward anymore. Think of your software as an elephant. and it keeps growing, and you keep trying to push it, and it's getting bigger and fatter, and eventually you can't push it anymore, and suddenly your project fails. The way to avoid this is to always refactor, all the time. As you're writing code, you will notice, wait, this would be better this way, this should probably change. I should remove the dependency on this from... Always keep your code clean as you write it. Second thing, and I recommend this highly to everyone, regardless of your deadlines. I have to have a deadline, I don't care. If you find code that is crap, rewrite it. If you find code that is hard to read, rewrite it. How do you have the confidence now that when you modify that code, when you change the implementation of a function or a module, that you didn't introduce bugs? You have tests. You have regression tests. Exactly. You wrote, remember, you changed your specs into check the scenes. You have automated tests that will tell you when you've broken your promises, remember? That's how you solve that. So keep your code clean as you go. I can't believe I have to say this, but I do. Format your freaking code, guys. Seriously. You will not believe how often I've come up to a screen where the code is like that. And when I ask the engineer, like, what are you doing? Oh, no, don't worry. This is the answer. I'm going to format before I push to Git. They're missing the point of formatting. The reason why you format code is so it's easier to read your code. When you're writing code, most of the time, you're not writing. Have you noticed that? When you write code, you're reading your code. Most of the time, you're reading. You do some writing, then you read, and then you read some more. Then you find a bug, you debug, and then you read some more. You go, you drink some water, come back, read some more, right? You're reading, so you want your code to be readable. So, okay, format your code, okay? All right, good. Avoid tight coupling. So this is a sort of general concept in software development, where when you have pieces of your system, these Lego blocks that you're using to build your software, minimize their dependency, right? Think of it this way. Have each one of these pieces have a shallow little channel through which they communicate with each other, known as the API, right? Keep your APIs as small as you possibly can, okay? And minimize your dependencies among your modules, all right? This way, first of all, you can change the implementation of any one of these pieces without affecting the rest of the system, right? And second, remember that your APIs are your promises. Promises are hard to keep. Minimize the promises that you make. Makes sense, right? So keep your APIs as small as you possibly can. Avoid premature optimization. I said this once, and someone raised their hand and said, wait, so are you saying I can write like crappy code? And then, no. I'm not saying use bubble sort, realize that bubble sort has this as far as performance, and then go, I should probably use a different sorting algorithm. That's not what I mean by optimization. By optimization, I mean like adding edge cases to make things go faster. I mean like adding a caching layer. This is what I mean by optimization. Optimization in every instance that I have seen adds code. Adding code adds complexity. Optimizations add complexity to your code. So be careful about adding optimizations. Only do so when necessary. Furthermore, make sure that when you do add an optimization, that you're getting the benefit of adding that optimization. In other words, make sure that you're actually measuring. If you don't measure, how do you know that this code that you added is actually doing anything, right? Also, it may actually do something in that case, but you don't see an effect because it's not the bottleneck. There's another part of the system that is slowing everything down. And any changes that you make to the rest of the system aren't actually modifying the time. So it's useless. You're actually adding complexity to the code without getting any benefit from it. So be careful about adding. If you add optimizations that don't change the runtime of the overall system, you added a bug, as far as I'm concerned. Don't make compromises to meet deadlines. This is where your professionalism comes in. A lot of you are probably using something like, they have sprints, right? You have these little milestones and you're found them, right? And then you're sort of running from one sprint to another. Okay, this is just a mechanism to keep you going and keep you working fine. But a lot of people will take shortcuts in their code, add hacks, do things incorrectly so that they can reach a deadline, right? Don't do this unless you absolutely have to. And in most cases, you don't absolutely have to. Right? So don't make compromises. Remember that any compromises that you make will add technical debt. And you will pay for that debt eventually. Right? So don't make compromises. It's better to not reach a deadline, but say, you know what, it's going to take another day or two, but I'm going to do it right. That is better than reaching the deadline and checking in garbage, as far as I'm concerned. Be careful about your naming conventions. One of the hardest things in software engineering is naming things. It's really difficult. I spend a ridiculous amount of time just trying to figure out how to name my variables or my components or what have you. But it matters, and it really matters. Because you want to make sure that, first of all, the names that you pick are not too long. If there's a shorter name, use it. But secondly, you want to stay consistent. An example. I, in my system, in almost every software that I write, means index. If I have a for loop, it's I. If I do for each, the second parameter, I. I always means index. Dollar always means jQuery. Blah, blah. Right? There are these conventions. And when you read the code and you see I, you never have to read the code to understand what I is. You know what it is. Right? This is what I mean. The advantage of being consistent across your naming is that people who read your code won't have to understand what it's supposed to do. They can take existing knowledge that they've gained by reading other code and apply it here and understand it's consistent. Right? Being inconsistent will introduce bugs. If I were to use I everywhere as an index, and then in one little place I used I as something else, that is a recipe for someone reading it wrong. Clear? Hit over mic chains. Use composition. What do I mean by this? So in software engineering, we all understand that we should never build big systems. What we should build are small systems, parts, Lego pieces, if you will, that we then combine together to form complexity. We all know this. Nothing new there. But there are different ways of putting code together. One way is through inheritance. Right? This is what Java does, this is what C# does, C++, and so on. And the way inheritance works is simply when you have some code here and you have some code here, this code up here gets merged and sort of combined with this code. Right? And now this code has access to the thing that has been merged into it and any modifications that it's made over the top. And you can sort of keep combining code from top down like this. This is one way of doing it. We have a notion of multiple inheritance. Often these are implemented as mixins, right? I think Ruby does mixins. There's mixins in JavaScript as well. And mixins allow you to basically take multiple pieces of code and merge them into one thing, right? This is one approach of combining code, of composing from different parts one thing, right? There's another way, which is to not squeeze them together, which is to not grab this and push it together and make it one thing. Instead, you keep it separate. You have this simply reference that. And when you need the functionality of this, you simply call it. You simply call it. You don't take it as yourself. You don't inherit from it. It doesn't become you. You simply call it and use it when you want. Composition. Yeah. I mean, yeah, that's a little different. Yeah. All right. So this is typically what's known as composition. And what you will very often see is this notion of, use composition over inheritance. Bless you. So if you think about it, to me, everything is, anytime you're taking code and putting it together, you're composing, right? You're taking parts and you're composing something. But typically, when you read composition means that. You take separate things and you combine them. You don't inherit. The problem that I've seen with inheritance is this. Inheritance, you try to create a taxonomy. And usually, you have to build this taxonomy up front. You build the taxonomy in the beginning. The problem with this is simple. The beginning is when you know the least amount about everything. Okay, ուրեմն մեմլ գիտես ինչ կենթանին ու մարդը կենթանին մարդը կենթանի է հասկանում ես այսինքն is a հասկացողություն է սա սրանից է բայց hierarchy-ն ինչ ասած կարող է hierarchy լինի չէ այս կոնկրետ բանի hierarchy է որ սա է հա okay Chogata? Cool. All right. The problem with, at the beginning, you know the least amount about your project, right? As you start moving forward and you start coding and you start reading your spec and you start talking, you begin to learn more and more about the product, right? Makes sense? So at the beginning, you know the least amount. Later, you know more. Anything you can do at the beginning to minimize change later is good. So building abstractions in your code so that you can change the implementation later without modifying the rest of the system or having an effect on the rest is a good thing, right? So that's one. The second thing is if you have to build your hierarchy, your class inheritance hierarchy at the beginning, later you're going to possibly realize, oops, and that oops is going to cost you a lot. With composition, if you're simply in your implementation referencing other code, later if you have to change it, change your implementation. Nothing else changes. You guys see that? This is the argument for composition. Now, I will say one thing. I'm not suggesting you don't use classes or you don't use inheritance. Because there are, if you're using Java, it almost forces you, well, first of all, you have to use classes. But you could theoretically keep a flat class structure, right? Theoretically, you could do this. But then it's weird. It's different. Everyone else on the team is using inheritance, and you're off like making static functions. And be consistent, but be aware of this method and understand its benefits, and try to use it whenever you can. Learn functional programming. This is, you will be a way better software engineer if you learn this. Yeah. Տեղ կա հայր, տեղ, չգիտեմ, եկեք, ստեղ լուջ եմ ասում, տեղ կա, եկեք, մտեք, դիմաց, don't be shy, come on. All right, so what do we mean, so why do I say this? Now, first let me just say a few words about what I mean by functional programming. So with functional programming, what we mean is writing code that doesn't modify, well, that doesn't have side effects. Writing functions that when you call them with some input, they have the same output. They don't have dependencies on anything outside of them, and they don't modify anything else. You give them input, they give you an output. And any input you give, it's always going to give you the same output, no matter when you call it. This is crucial. By writing code in this way, you eliminate the problem of time. If your function has a dependency on an external variable, depending on when you call it, it will give you a different result because the state of that variable can change, right? That adds complexity. It also makes this function harder to test. So whenever possible, keep your variables local and isolated within a function. Keep your dependencies low. Learn functional programming and use it when you can. You can't write all your code this way. At some point, you have to modify the database. That is changing state outside of the system, right? That's non-functional. That's bad. But in many cases, you can write code this way. So if you want to be a better programmer, learn functional programming and try to apply these concepts to your code whenever possible. It will simplify your system immensely, I promise you. Security matters. Security matters. You can't have a high quality product if you have crappy security. And the problem here, and managers, here's the problem. It's very easy to not do this. It's very easy to not worry about security and show a beautiful product to the customer. And they go, wow. And then they ship it. And it's awesome. Everybody loves it. And then they get hacked. And identities are stolen. Credit cards are really bad thing. That's a bad quality product as far as I'm concerned, right? But again, visually, when you look at it, you think you don't know that it's a bad quality product, right? So security really matters. Now the problem, and I have a real problem with this, and it's a major problem, and I've lost sleep over this, is that with security, it's an opt-in model. The default is non-secure. If you don't know what to do, if you don't write your code in a way that it is secure, the default is that it is insecure. The default is you will get hacked. And it only takes one mistake, and someone will find that mistake, and they will get you. So that sucks. So what can we do? Wow! So one thing you should do, first of all, always, is never, if you're writing a server, you're writing a bunch of services, right, that talk to the outside world, that talk to your clients, never trust the data coming in from your clients. I've seen code where people will write JavaScript to validate the form. That's good. But it's good for the user. It's meant to be a user. It's meant to help guide the user right in the right thing. It's not meant to keep your code, the data of your code, the integrity of your data. That's not what it's there for. It's there to help the user write the right thing. Once it goes to the server absolutely has to do the proper validation and scrubbing of that data before it writes to the database or does anything else with that data. Right? Okay, yeah? Yes. So never trust the clients. Okay? Always, no matter what you get from the client, always make sure you do proper validation and scrubbing of your data. This is an example of how it's easy to get it wrong. Programmers usually go through this phase. They learn strings. Okay, got it. Strings. Quotes. Okay, good. They learn concatenation. Okay, I can take this string, I can put it together, make a bigger. Okay, good. They learn that they can concatenate other data types because, say, it gets stringified and gets converted into a string. So they say, okay, I can take this variable, concatenate it with this string, and it becomes this other string. Good. Then they learn SQL. Or whatever query language, I don't care. And these query languages are typically text, they're strings. Okay, so they say, oh, so I should be building a string to give to my database. So far, it all makes sense. So far, our logic is sound. And so they do something like this. They'll write a query where they will write some query, it doesn't matter what it is, this is just one example, and they concatenate a value that they received from the client. And their database gets dropped because someone did, X, get started, get dropped, exactly, right? Orinak. Updates can be modified and so on, right? You can do some really bad things with this. The right way to do it is more complicated than the default way. The right way is to maybe put in a question mark and then have the framework or whatever library that you're using do the proper escaping. This is harder than this. Intuitively, we want to build a string, not make an extra argument to a function that then maybe does something weird, right? So our intuitions in programming are wrong. This is bad. That means most people are writing crap. Most people are making mistakes in their code. That's why you get SQL injection attacks all over the world. So the only way to prevent this is to just know to do it this way. So you just have to do a lot of learning before you write code and probably make mistakes, deploy code, get hacked, go oops, and then learn from it and do it right the second time. So it goes. That's life. There is no security in obscurity. A lot of people try to hide information. They make it difficult to find. The problem with making things difficult to find is that eventually someone will find it. Putting roadblocks doesn't stop someone, it just makes it harder. It's difficult to keep promises. I think this is almost the theme of the day. It's hard to keep promises. The more promises you make, the harder it is to keep them. I think we've made this case. So minimize what you have to keep, the promises that you have to keep, the secrets, I'm sorry. Minimize the secrets that you have to keep. Blah, blah, blah. I meant secret. The more secrets you have, the harder it is to keep them, right? Okay. So the only secret that you should keep is your keys. Don't keep secret the process by which you cipher them. Don't keep secret the hash code. Don't keep secret any of the actual code that tries to do the transformations, the decryption, the encryption. None of that should be a secret. The only thing that should be a secret is the key. Everything else, you can open source it if you want. Because that's the only way you have the right discipline, that you have the right mathematics in your encryption algorithm. Otherwise, you're just adding a roadblock, and eventually someone will figure it out and you will get hacked. With everything I said, with all the patterns and all the things that I've learned as an engineer, there's one constant, and that is that there's no substitute for knowledge. There are no rules. There are no, do this, this, and this, and you will have a great product. There is no formula. There is only knowledge. And the more knowledge you have, the more experience you have, the better code you will produce. There is no rules for how you're supposed to refactor. It comes with intuition. It comes from reading enough code and writing enough code and struggling with enough code that you end up understanding what works and what does not. It's entirely based on intuition. It's entirely based on your experience with software. There is no substitute. 3-year JavaScript programmer is not a senior JavaScript programmer, no matter how good you are. If you've been writing code for 3 years, you haven't seen enough code. It's that simple. Also, always learn. A lot of managers, quick thing for managers, it should be part of your sprint to educate your engineers. I don't care if you have a deadline. I don't care if you have a customer breathing down your back. Education is absolutely key. Why? Simple. The smarter your engineers are, the better code they will produce. The better solutions they will produce. We don't want stupid engineers. The smarter engineers we have, the more value we get from them. Education is absolutely key. And the last thing, so if there's one thing I hope you will take away from this talk, it's this. And this slide actually comes from Robert Martin, also known as Uncle Bob. He has a lot of videos on YouTube, really smart guy. And it is, and this is sort of a mantra, we will not ship, that shit, yeah. Never let anybody, I don't care if it's your manager, I don't care if it's your boss, I don't care if it's the customer, I don't care who it is. Never let anyone affect the integrity of you as a developer, as a professional. You know when you've taken shortcuts. You know when the software is not ready to deploy. You know when what you've created is shit. Never let that go. Never let that go out into the world. Your job as an engineer is to not produce code. If you think that's your job, you're wrong. That's not your job. Your job is to produce solutions. And solutions require programs that work, programs that are correct, programs that are secure, programs that are bug-free. If what you've produced is not this, then you haven't done your job. And if you haven't finished doing your job, you're not done. If you're not done, don't deploy. Do not deploy. I'm telling you. You will get pressure. We have a deadline. We have a customer yelling at us. I don't care. Quit if you have to. Don't let that shit go out. Thank you. So we're pretty good on time. So very quickly, again, I'm looking for a JavaScript engineer, so email me. If we're not friends on Facebook, you dick. So we have some time for questions. We have about 20 minutes. So I'm here. Please, hit me. Not all at once. Hajan, this one.
Are you using JavaScript classes ES6?
Good question. Yeah.
For inheritance and complex dot.
Yep, I understand what you. Okay, so so just some background. So JavaScript for a long time had prototypal inheritance, and this was actually inheritance and composition kind of mixed together. The reason why it was mixed together is because it was inheritance in the sense that yes, you do now when you call attributes of that object or functions of that object, if it doesn't have it, it goes and inherits it from its parent or prototype, right? But it was composition in a sense that things were not actually getting merged together. Instead, there was still a separate component that was referenced via this weird underscore underscore proto underscore underscore reference. So it was a hybrid almost, right? It was this weird, somewhat inheritance, somewhat composition thing.
Inheritance, not class inheritance.
Right. It's object inheriting from objects. But the point is, the two objects don't mix in together. They are actually separate objects. Yeah, absolutely. John. Right. So this was the sort of the approach that has been used for a while. And then people who were Java programmers would come in and not understand that this is how it works, and they would complain. And they complained so much and jumped up and down and yelled and screamed and whined and cried that the good people at ECMA, the sort of ECMAScript is like the standards version of JavaScript, decided to, in the next version, ES6, whatever, have a notion of actual classes that work like Java. So your question was why, maybe my opinion of it and whether I use it. I hope not. So let me explain. So JavaScript was not supposed to be the way it was. It was never intended to be what we now use. It was supposed to be Scheme. Anyone know Scheme? It's a variant of Lisp. Anyone know Lisp? You know Lisp. Oh, very nice. Oh, yeah, very cool. Okay, so these are functional programming languages. They're actually purely functional, I believe. This is what Brendan Eich wanted to implement in the browser. The problem with Scheme, or so they say, is its syntax. It looks a little different from what your traditional programming languages look like, right? And so when Netscape saw what Scheme was, they said, no, blah, 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 no. Do something that looks like Java. And so Brendan Eich went, okay, fine. And so he implemented this thing, but he still put in lambdas. In other words, he treated functions like values, which is, I think, one of the things that really gives a lot of power to JavaScript. And then he also put in prototypal inheritance. I can't remember what language he took that from, but it was an interesting idea. And so we got JavaScript. And he did this in about 2 weeks, which is why we got a lot of the bad stuff. Because you can't do good software in 2 weeks. You just can't. In my opinion, I think classes kind of go against the mantra of the language. Every language has something that makes it different, something that makes it unique. I don't think there is a language that is meant to do everything. I wouldn't use JavaScript to write a database. I just wouldn't. I wouldn't use C++ to write client-side applications. Every language, in my opinion, has a purpose. And it is the goal of language designers, when designing a language, to understand the purpose for which it is being created. Sometimes the language is also applicable in other domains. Sure. But usually there is an understanding that we are building this for that, right? And I think that by some of the modifications that have been made to JavaScript, including the introduction of classes, was not to enrich JavaScript in what it was meant to do, but it was to make it look like a language that it is not. And so to me, this goes against the mantra of JavaScript. This goes against the mantra of writing things functionally and using composition. It goes back to Java. It goes back to inheritance. It goes back to what JavaScript was fighting against, in my opinion. And now they have almost given in and put it in just to make some engineers who are Java engineers happy. And that pisses me off, to be honest. In charge? I mean, just, yeah. So here's the thing. In languages, you can't get rid of things. This is the problem with languages. You can't remove things. Because if you remove things, you break code. The best you can do is, so for example, you can write code where your compile or your interpreter runs a little bit differently if you tell it to. Again, in JavaScript, you can write use strict at the top, right? And use strict means run in strict mode. So the interpreter that runs your JavaScript will read that and go, ah, okay. And suddenly it won't let you do certain things, right? It will turn off with, for example. That will be an error if you use that. So there are little tweaks that can be made that way. But generally, it's very difficult to modify an existing language. It's usually better to just make another language. And if you have to compile that language into the language that everyone is using and do that, that's what TypeScript did, right? With the transpilers, that's what a CoffeeScript is, another syntax that compiles into this. Go, I think, does this, right? There are a bunch of these. Dart, that's what I meant. Even C++, actually. You know, you guys can compile C++ into JavaScript? Pretty crazy. Java into JavaScript? Google was doing this way back, right? Because this is great. Google's like, okay, we need to write web applications. We have a bunch of Java developers who don't know JavaScript. We can either A, teach them JavaScript, and then someone might wait. I have an awesome idea. I will write a compiler that will compile that, and the guy got a bonus, and yeah. Meet that second. Yes, sir.
The question is about the subject of the composition. We talked about the different composition, especially in Java.
Yep.
About the inheritance and different kind of objects.
Yep.
What about the interfaces, implementing interface? This thing interface implementation it
right.
will be happening with the combination of the hardware and software, because you need to check everything in the loop, and it would be something like an engineer to raise an event when something logically happened.
Right,
into
right.
another, into the main thread, into another class.
Was your question basically about polymorphism? Cool. Okay. Hands up if you don't know what polymorphism is. Okay. 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 So the idea behind polymorphism is this. Let me think how I can explain it as an example. So you write a function, and you want it to apply to people. Okay. No, you want it to apply to animals. So it's a function that takes an animal and then does a bunch of things, calls a bunch of functions and whatever. But you have humans who are animals, right? And they have their own implementations of those functions that are different from, say, a cat, right? But both of them can be passed to the same function because it doesn't care about the implementation. It just cares that it's an animal. The specifics of the implementation can change, can morph, polymorphism can modify, based on context, right? Is that do okay? Okay, cool. So I know what it is. All right, good. So how would you do this with composition, is your question. So you still have a notion of objects. They don't inherit from each other, you're right. How would you do this? So one way I think you could do this is, so with composition, implementations change, right? So you have a function that has some implementation. You have another function that has a...
In this case, for the interfaces, we have classes.
Yeah.
We have an object.
Yeah.
When you want to raise an object, raise an event from that object into the other, you will not call it a function. You will call an interface of that.
You will call it. Are we talking about the same? An interface is just it's okay. So in Java, right? You have classes and interface which you implement, right? Yeah. So it's an interface in Java is just a promise. It says I guarantee to have these functions. Yes. Okay. So we are talking about the same thing. So you have an object that has a bunch of functions implemented. You have a completely other object that has the same functions implemented, but implemented maybe differently. Yes? Yes. And so you have a function that knows how to take anything that has implemented those set of methods, and it knows how to call those methods. But what happens when it calls it depends on which one you pass in. Yes? Cool. So your question is, how would you do this with composition? Good question. The answer I'm going to give you, you're not going to love. Because, so one way that I've done this is, rather than passing objects, I pass functions. Now in Java you can't do this, I know. So just, we're not talking Java, we're talking languages that are good. Okay. All right. So in languages that are good, so Python, JavaScript, a lot of these. Yes, JavaScript is good. I don't want to hear it. All right. oh no, actually no, I'm sorry. Java has lambdas now. Yes, yes. Woo! How did they get lambdas? A bunch of functional programmers jumped up and down, and we finally convinced them to. They modified JavaScript so much. They added classes, right? Now we finally got them to add something. So we're winning, sort of. Okay. So you pass a function as an argument to that function. And the implementation of that function can change. So the function body of the function that you gave it can differ depending on the caller. Eh? Yeah. Urish. Yes, sir.
Just regarding the polymorphism thing, but the polymorphism use case is sort of different than composition, and it also depends on you're working on a functional programming environment like JavaScript,
right? And
it also depends on you if you're working in Java, because it's a totally different motivations for use a polymorphism or use a composition.
Yeah.
So I'm just trying to make a small remark about that.
Yeah, no, you make a good point.
It depends. I mean, the question is good, but I want to say just that it absolutely depends on the type of a problem you're solving, and the polymorphism most probably doesn't make sense to think about in a like JavaScript-like environment, because the solutions and tools are sort of different there. Like it's functional, and then you kind of choose sort of a different path. Whereas in Java, you probably a few use cases kind of require you to use polymorphism, like you're building a framework and stuff like that. But yeah, just
no, great point. I mean, absolutely, no, this is great. You can wait. So think of it this way: when you write in a language for long enough, you start to think in terms of that language. Even the syntax modifies your thinking, right? A lot of people, I will talk to a Java programmer right away. They're like, "Oh, so a class? Like, no, object. Also, the class that no, just object. What do you mean? How did you get the object? If you like the idea of having an object without a class that then becomes the object doesn't. It's because that's okay. Look, I'm not blaming them. I also think differently because I'm a JavaScript programmer, and when I think object, I think just object, right? I don't think you have to make this other thing that turns into right. And it's okay. And so because we think a little bit differently and we approach things a little bit differently, the solutions that we come up with are obviously going to be a bit different. They're going to be influenced by not only the language that we use, but also the frameworks we use, right? How you code in Angular is different from the way you code in React. Not to say that we can compare because one is a library, one's a framework, I know, blah, blah, blah. But the point is, in different contexts, you end up making different decisions. Now we can zoom out and have a general understanding of, yes, but which is actually better. We could do that. We could have that argument. But in order to have that argument, you have to know more than just one language, right? Which is why, going back to the slide before the shit slide, the knowledge one, learn languages. Learn as many languages. You guys know that the more languages you speak, the better understanding you have of the world, right? Because every language has concepts that other languages do not. And so they give you a better understanding of the world, right? Knowing Russian, Armenian, English, it's a good thing. Same thing in programming. The more programming languages you know, the better you can begin to reason about various concepts. Otherwise, everything is a class. Yes, sir.
I think the best answer might be to avoid comparing the mechanism of different languages. Like this is Java, and this is the equivalent of Java in JavaScript. Just we need to avoid finding the equivalent mechanism. We need to look back and try to say this problem can be solved in Java this way, and this problem can be solved in JavaScript this way.
Right. That's a good point.
To think about the solutions, not the equivalent mechanism to transfer the code in one code base into another code base.
Right.
Okay.
That's excellent.
That might become a successful solution, not to find the equivalence.
Absolutely. No, that's a great point. Great point. Thank you. Anything else? John. We have 5 minutes according to the paper to my left. Anything else? Jonah. Yeah, I think I already posted. I'll post a link on Facebook. Cool. Anything else? Did I mention I'm looking for a JavaScript program? full time. Don't you know? Can I work from home 2 hours a day? No, work with me all day.
Have you ever been hacked?
Have I ever been hacked? Well, that's a very good question. Have I ever been hacked? Yeah, but not the way you think. No, that's not. No, I have a WordPress site. If you go to RubenMeschian.com, it takes you to the WordPress site. And so I didn't write the WordPress, obviously. But yeah, someone hacked the WordPress and bad things happened. And my provider locked it down and changed permission. Anyway, but yeah, no, because, okay, so with my case, I'm a little safer because most of the code that I write, most of the code, not all the code, but a lot of the code is business to business. Until recently, actually, but a lot of business, and a lot of their code runs inside of their firewall, so it's not available to the external world. So it's kind of locked down in a sense. So I've been somewhat okay in that regard. 222. Yeah, because this works, right? Thank you for the question. Thank you. Uri Shavsar?
What was the most interesting project that you have ever done? Like, that you love it the most? Product or project?
Wow. The most interesting, the problem, see, okay, so I've done a lot of small projects, but then the Cambridge semantics stuff I've been doing for a really long time. And the reason why I really love that stuff is because Cambridge semantics is solving really cool problems, and their approach is somewhat new. Whenever you build web applications now with like Angular and React, like how many applications are out there with like standard Angular React knockout? You know, you get some JSON in, you do some data binding, you throw it on the front end, you take it, you make some modifications, you have CRUD on the server. And it's like you're doing the same thing that you've done 50,000 times, but a little different, right? I'm not suggesting that that stuff isn't awesome and that there's not a lot of interesting work to be done there and that you can't build really exciting solutions with this. But technologically speaking, purely technologically speaking, I can usually find a solution to any problem that I have, usually on Stack Overflow. You go there, someone has probably had this problem and you can figure it out. I like solving problems that don't have solutions on Stack Overflow. I like solving problems where like you just have to figure it out. You know, you don't sleep nights, right? You hit your head against the wall. That usually doesn't work, but you do it anyway. And then eventually you solve the problem. And so the problems that I think Cambridge Semantics is trying to solve with their graph-based approach have been the most exciting in my experience. Technologically, because I'm an engineer and I'm a nerd. Nerd power. Hajim.
Graph database դուք եք գրել թե
մենք առել ենք այդ ընկերությունը, որը ստեղծել է։ Այսինքն մենք արդեն դե ես փայատեր եմ, вообще մենք, հա։ Մենք օգտագործում ենք մի հատ distributed database, իրանք շատ լավ թիմ էր, Stonebreaker-ի ընկերներն էին։ Stonebreaker-ով է։ Postgres։ Ինքնասակ է։ Պապանա։ Relational բազաների պապանա come on, MIT professor, Stonebreaker, Michael Stonebreaker, հիշեք։ Բանը, so իրան գերներն էին, իրանք սարքեցին այդ բազան, հետո մենք իրանք ծառանք։ Հիմա իրանք inherit արեցինք իրանք։ Ժամանակին composition էր, հիմա inheritance-ը։
Իրանք inherit արեցին։
Ոնց ասես։ Ոնց ասես։ Հա ճիշտ է, ոնց է պապան մենք ենք, չէ՞։ Պապան է։ Թուղթը ինչ է ասում։ Լավ, շատ շնորհակալություն։ Okay.